Hi, my name is Hannah.
And my name is Sam. And we're going to be talking about log functions.
And how we take a log and turn it to an exponential and vice versa. And they're called inverses. So this equation is the logarithmic equation. And what you do to get to exponential is you take this x, you replace it with the y, and then the y replaces the x. And we call this the cat chasing the mouse. So the x is the cat, and this y is a mouse. And so that would help you remember that a cat chases the mouse, and they run in circles. Okay. Now, right here is the exponential equation. And as you can see before, here's the cat, and here's the mouse. Now you see they've switched, but the base stays the same. So, same base. And so, okay, and so from an exponential to a log, you just switch them again. You just do the cat chasing the mouse, and then you end up with the logarithmic equation.
Okay, as Hannah just talked about, she explained to you the equations. Now we have those written over here so that way as we're working out all of our equations and example problems, you can see the formulas. Now switching from a logarithmic to an exponential is called an inverse. Let's get started with going from a log to an exponential. So as you see here, we have log 3, 9 of 2. Now if you remember the cat chasing the mouse, it's going to switch to the 3 stays, because the base never changes. 9 is going to go there, 2 is going to go there. It's going to go log, and the log goes away, so it's going to be 3 squared equals 9. Now, that's a logarithmic to an exponential. How about we try a exponential to a logarithmic? Now this is the same thing. So, what we're going to do is it's going to change a log to, because remember, this is the base, and it's never going to change. And then you're going to have a big, the x is going to become the 8, and the y is going to become a 3. Now, just to show you how, the log 3 to 3, the 8 switches. So, like I said, 3 goes to the 8, 8 goes to where the 3 was, log 2 of 8 equals 30. How about we try an exponential? Now here, we're going to be taking an exponential to a logarithmic. Now if you remember, the base doesn't change. So we're going to use the cat chasing the mouse theory. So it's going to be a log 4 64 equals 3. Now, since we're just changing it from an exponential to a log, trying to switch it back would be a log. You get rid of the log, it would be 4, 3, 64, which is back in our original problem. Let's try one more log to an exponential, but this time we're going to have a negative number and a fraction. Now, if you'll remember, if you take 3 to the negative 2 equals 1 over 9. So therefore, this problem works out. So, going from a log to an exponential, this is going to go 3, negative 2 equals 1, 9. Now if we plug this in the calculator, you can see 3 up negative 2 equals 1 over 9. So this problem works out. Now, the 3 common mistakes that people often make, I'd have to say, is you switch all 3 numbers. Now what I mean by that is you'll have a log b of x equals y. Now what people sometimes want to do is the b goes to where the y is, y goes to where the x is, and the x goes to where the log b normally goes. So that is wrong. I know you'll want to do it. It looks like a circle. That's not right. The second common mistake is when rearranging numbers, the base of a log cannot be negative in a logarithmic problem. So the base of a log cannot be negative because that's not a real log. And this is how you learn how to rearrange log functions and vice versa.
Thanks for joining us. Hope you join us again.